Good morning, students. Today we will discuss about half range sine series. Already we know about Fourier series expansion of a function f of x. Fourier coefficients a naught, a and b n are Fourier coefficients. In half range sine series, a naught equals to 0 and a n equals to 0. These both Fourier coefficients are 0. Now we will see the definition of Fourier half range sine series. The half range Fourier sine series expansion of f of x is in the interval 0 to c is given by f of x is equals to summation n equals to 1 to infinity bn sine of n pi x upon c, where bn is equals to 2 upon c integration 0 to c f of x sine of n pi x upon c dx. Now see here, while finding half range sine series, these two Fourier coefficients a naught and a n are 0. Therefore, we will calculate only the value of bn. Okay. Now, see one example. Question is expand f of x is equals to pi x minus x square in a half range sine series in the interval 0 to pi. Now here f of x is equals to pi x minus x square. Now interval 0 to c is here 0 to pi. Therefore your value of c is c equals to pi. Now half range sine series is given by f of x is equals to summation n equals to 1 to infinity bn sine of n pi x upon c, equation number 1, where bn is equals to 2 upon c integration 0 to c f of x sine of n pi x upon c dx. Now put the value of c, value of f of x. Therefore bn is equals to 2 upon value of c is pi. Therefore it becomes 2 upon pi integration 0 to pi f of x is pi x minus x square sine of n x only, because value of c is pi. Therefore pi get cancelled, only nx will remain here. Now using generalized by parts rule, 2 upon pi equals to pi x minus x square integration of sine nx is minus cos nx upon n minus derivative of this first function u dash pi minus 2x it will be, and again the integration of this term which is minus sine nx upon n square, again derivative of pi minus 2x is minus 2, and integration of this term it become minus plus cos of nx upon n cube, limits from 0 to pi. Now after substituting upper limit and lower limit, you will get bn is equals to 4 into bracket 1 minus cos of n pi upon pi n cube. Okay, now this is the value of bn. Therefore equation 1 becomes f of x is equals to 4 upon pi summation n running from 1 to infinity 1 minus cos of n pi upon n cube sine of nx, which is required half range sine series. Okay, this is required half range sine series. Now second question, obtain half range sine series for the function f of x is equals to 1 upon 4 minus x, 0 less than x less than 1 half, and this equals to x minus 3 by 4 1 half less than x less than 1. Now here interval 0 to c is nothing but 0 to 1, this interval 0 to 1. Therefore c equals to 1 here. Now half range Fourier sine series is given by f of x is equals to summation n running from 1 to infinity bn sine of n pi x upon c, equation 1, where bn is equals to 2 upon c 0 to c f of x sine of n pi x upon c dx. Therefore substituting the value of c here, therefore 2 upon 1 means only we will write here 2 integration 0 to 1 f of x sine of n pi x, value of c is 1, therefore n pi x will be there only dx. Therefore this equals to 2 times integration. Now this 0 to 1 interval, see the definition of f of x here. This interval is divided into two parts, 0 to 1 half and 1 half to 1. Therefore this integration will also divided into two parts, 0 to 1 half. 0 to 1 half value of f of x is 1 by 4 minus x sine of n pi x dx, and again integration 1 half to 1, value of f of x is x minus 3 by 4 sine of n pi x dx. Therefore now see here, using again generalized rule of by parts, 2 times 1 by 4 minus x minus cos of n pi x upon n pi minus minus 1 into minus sine of n pi x upon n square pi square, limits from 0 to 1 half, again plus by parts rule for second term, it becomes x minus 3 by 4 minus cos of n pi x upon n pi minus 1 into minus sine of n pi x upon n square pi square, limits from 1 half to 1. After substituting this upper limit and lower limit, you will get this bn is equals to minus 4 upon n square pi square sine n pi by 2 plus 1 upon 2 times n pi 1 minus cos of n pi. Therefore equation 1 becomes, now substitute this value of bn in equation 1. Therefore it becomes f of x is equals to summation n running from 1 to infinity minus 4 upon n square pi square sine of n pi by 2 plus 1 upon 2 n pi 1 minus cos n pi bracket complete sine of n pi x, which is our required half range sine series.